Conservative and non-conservative forces. Objective: to differentiate between conservative and non-conservative forces. We know that work done by a force is equal to the dot product of force and displacement. Let us look at the work done by two different types of forces, gravitation and friction. Consider an object taken from point A to point B along the curve y of x near the Earth's surface. Let us calculate the work done by gravity when object moves through an infinitesimally small distance dr from a point P on the curve. Dr is the summation of its displacement along the x-axis dx and its displacement along the y-axis dy. Gravity acts along the y-axis, so work done by gravity dwg is minus mg dy. The total work done by gravity from A to B is integral of minus mg dy from y1 to y2, which is equal to mg into bracket y1 minus y2 bracket closed. Observe that work done by gravity depends on the initial height y1 and the final height y2, and that it does not depend on the shape of path taken by the object between those points. So, it can be said that irrespective of the path between points A and B, work done by gravity is the same. If the object is brought back to A through another path, as the initial and final positions remain the same, the total work done is zero. Such forces whose net work done in a roundabout motion is zero are called conservative forces. Work done by a conservative force is independent of the path taken. It depends on the initial and final position only. Gravitational force, spring force, and electric forces are examples of conservative force. Now, let us look at work done by friction in a roundabout motion. Consider an object of mass m that is moved very slowly through a distance d between points A and B in a straight line on a rough floor with coefficient of friction mu. The frictional force that exists between the surfaces is therefore mu mg. Friction, as you know, acts opposite to the direction of motion. Hence work done by it is minus mu mgd. Now consider another situation where the object is brought from A to B very slowly along a circular path of radius r. Frictional force along the circular curve is mu mg, and it is opposite to the motion of the object at every point. Hence, work done by friction in this case is minus mu mg pi r. Though the initial and final points are the same in both cases, work done by friction is different. So, work done by friction depends on the path taken by the object between initial and final points. Irrespective of the path taken to bring back the object to point A, total work done in the roundabout motion is not zero, as friction acts on the object throughout the path in a direction opposite to that of its motion. Such forces whose work done is not zero in a roundabout motion are called non-conservative forces. When non-conservative forces are at play, energy escapes the system, mostly in the form of heat.